Thank you for joining today's discussion. We're going to be talking about Northrop Grumman's approach to the Future Vertical Lift program. I want to thank you all for taking the time to jump on this call today. We haven't spoken a lot specifically about Future Vertical Lift in the past. What you've probably seen a lot from us is mentions of various technologies and capabilities that are applicable to Future Vertical Lift. And so what we're doing today is we're going to kind of bring it all together and give you, how Northrop Grumman is really approaching this as a whole of company. So just to introduce the briefers today, we have Jim Conroy, who is our Vice President of Emerging Systems and Strategic Initiatives for Navigation, Targeting, and Survivability. We have Brendan Kelly, who is the Director of Future Vertical Lift for Northrop Grumman Mission Systems. Jenna Poxtus, who is the Vice President of Communication Solutions for the Networked Information Solutions Division. We have Susan Bruce, who is the Vice President of Advanced Tactical Systems for the Airborne Multifunction Sensors Division. So with that, I'm going to pass the mic over to Jim Conroy, who is Vice President of Emerging Systems and Strategic Initiatives for the Navigation, Targeting, and Survivability Division. So over to you, Jim.
Good morning, James. Thank you very much for the opportunity to share some of the great work that Northrop Grumman has been doing in Modular Open Systems Architecture, or MOSA, and survivability. As you know, Northrop Grumman has been supporting and continues to support the U.S. Army and their partners as they modernize their aviation fleet. We are uniquely positioned to provide the proven, integrated, open, multi-domain capabilities. Our approaches ensure that all future and enduring platforms are going to be lethal and survivable in the multi-domain operational environment, or the MDO environment. Whether performing any of the typical missions that these platforms require, the rotary and vertical lift aircraft greatly multiply the effectiveness of ground forces. They are a critical combat multiplier, as well as a lifeline in those difficult environments. Future Vertical Lift will transform the Army aviation fleet, bringing faster, more lethal, more survivable aircraft to the battlefield.
Thanks so much for that, Jim. So now I'll pass it over to Brendan Kelly, as I mentioned, the Director of Future Vertical Lift for Northrop Grumman Mission Systems. So over to you, Brendan.
We are finding that the Army already owns MDO-capable systems in their individual instantiation. The threat has always paced the development of those systems. What is going to be important is the integration of those systems so that we can optimize the size, weight, and power commitments that are made on the platform's behalf to those systems. As I say, they need to earn their way on. We can increase the operational capabilities of those systems. And in theory, if we do this right, reduce the overall lifecycle costs and ownership of those systems for the Army by introducing that agility that Jim mentioned in the form of MOSA. As we look at other systems that the Army has described as needing, things like a multifunctional radar, communications, navigations, and identification systems, that in theory could be a shared set of functions in that hardware-enabled world that Jim described to you. We're making sure that the interoperability is also part of what we're offering. So interoperability doesn't mean that it can just exist on the platform in the same chassis. It means that waveforms that go between the radar warning receiver, and things in that communication, navigation, and identification suite all aren't going to conflict with one another. And then that, again, extends outside the boundaries of the aircraft. Those unmanned enablers that are off the wing of these manned platforms also can't be impacted by that. So to make sure we get that right, we've undertaken a model-based approach. We have collaborated with the Army to develop operational models and vignettes. We've shared threat libraries, and we're using a common modeling tool. And then we're using the very same environment to model the individual functional characteristics of our systems, and then sharing that information with the Army to ensure that first, we've done no harm to the core competencies of these systems that have already proven themselves and are in the process of being fielded, and then define where the trade space is so that we can identify where we collectively see that integration and interoperability opportunity. As we look forward to what the Army needs to do, MOSA is a critical, cross-cutting feature. So it's not just the architecture that you see described in the form of the digital backbone, which is critical to this aircraft maintaining operational relevancy in the face of an ever-evolving threat. It's also something that we want to ensure is flowed into the mission systems themselves so that we can enable that innovation. And in many cases, that will be from third parties. We want to create that opportunity for the Army to rapidly iterate, maintain best value, and keep these systems relevant that they've made significant investments in as long as possible, and not get caught off guard by something they haven't planned for when the enemy turns the war mode on a lot of these threats.
Thanks for that, Brendan. So now we're going to pass it over to Jenna Fox, who is going to talk to us about communications, navigation, identification, as well as advanced networking. So over to you, Jenna.
Thank you, James. Northrop Grumman's Communication, Navigation, and Identification, or CNI system, is really uniquely positioned to help the DoD realize its networking vision for future vertical lift by providing 3 discriminators in terms of low size, weight, and power, cyber secure and software-defined technology, and scalable open architecture functionality to provide advanced networking and communications capabilities. On the first, Northrop Grumman is an industry leader in delivering low size, weight, and power CNI systems, like those that are used on F-22 and F-35, where we provide more than 27 different communication, navigation, and identification functions in an integrated solution that has proven performance in aviation environments. And these solutions are platform agnostic and provide enhanced situational awareness and improved interoperability for the warfighter. For future vertical lift specifically, this low size, weight, and power translates to improved time on station and increased payload capabilities. Second, our CNI system leverages its proven software-defined radio offerings and market-leading multi-level security technology, which is really a key differentiated technology that moves critical information through various classification levels to ensure the secure and trusted transfer of mission data across multiple domains. And the ability to communicate across all services at all security levels will be absolutely essential for the future of multi-domain operations. The software-defined nature and open architecture enable the system to be easily integrated onto rotary wing platforms and then upgraded to adapt to the emerging future vertical lift mission demands, which reduces the overall life cycle costs. And last, as Jim and Brendan have already discussed in terms of MOSA, the scalable open architecture functionality of our CNI system will enable the use of third-party sensors and solutions that will be critical to bringing new capabilities forward when our customers need them faster than ever before. And the only way to accomplish this is to leverage the advancements we're making in secure and ethical artificial intelligence and machine learning, advanced networking, real-time situational awareness, and beyond line of sight offerings, among many others. In addition, the software-defined open architecture functionality enables that rapid deployment so we can quickly adapt to the emerging mission needs and provide an affordable growth path for future capabilities while reducing that total ownership cost. James, I'll turn it back over to you.
Great, thank you, Jenna. So with that, I'll turn it over to Susan Bruce, who's going to talk about future vertical lift radars. So over to you, Susan.
Thank you, James, and good morning. One of the things, building on what Jenna, James, and Brendan said, the complexity of our modern warfare is really increasing the need for adaptability, all-weather, extended range operations, and the interoperability, and it's become more important now than ever. Northrop Grumman is able to leverage solutions and experience of decades of radar experience to provide an affordable, advanced, multifunction system that can perform air-to-air, air-to-ground, and air-to-surface superiority to support the U.S. Army's multi-domain operations. Today, I'm going to hit on several tenets that are enabling our future vertical lift radar approaches. The first one is building on the proven performance and a demonstrated adaptability to changing threats. We look to strive to provide advanced capabilities for our warfighter to operate in very complex electronic environments and in challenging, often degraded visual environments. Northrop Grumman has been a pioneer in our active electronically scanned array technology, or AESA radars, and has been in the forefront of AESA innovations over 5 generations and decades of experience. We have over 60 years of extensive radar experience, including several decades with AESA fire control and surveillance radar technologies that enables us to provide these air-to-air, air-to-ground, land, and sea superiority for the world's armed forces. We've been continuously working to improve and to develop advanced designs while reducing costs and increasing mission capability. By leveraging microelectronics and commercial manufacturing technologies, we've developed a new family of innovative designs and architectures and systems that offer robust performance in very highly integrated, affordable, compact, low-swap packages that are designed and extensible for growth. Furthermore, multifunctionality and adaptability are key to be suitable for the future vertical lift and to keep up with evolving threats. We currently are providing radars across our services that operate for surveillance, targeting, and engagement capabilities for both the Army and our allies, including the Apache Longbow Fire Control Radar and the Gray Eagle Starlight Surveillance Radars. By leveraging this experience across these different services and mission domains, we have designed in core capabilities that can support tactical operations all the way from target detection through engagement and battlefield damage assessment. Multifunctionality that's inherent in all of our RF systems. All of this together also provides major improvements in system reliabilities and lower sustainment costs. Our scalable designs share common hardware across multiple platforms where spares and repairs can benefit from shared expenses and further reduce the Army's total cost of ownership. The final point that I have also in our development, which is common to all of our things, but very key in the radar products, and similarly all the products across Northrop Grumman, is all of our digital transformation activities that's applicable through the full product life cycle. From requirements generation through interactions with our suppliers, development of digital twins, and use of digital tools to support production and sustainment, we're developing and utilizing a full digital infrastructure that really can support our ecosystem of development through sustainment. And with that, I'll turn it back to you, James.
With that concludes our session. Have a great day, everybody. I hope this was valuable to you.